Hey, welcome back. This is 12.3 on the properties of logs. Logarithms are capable of changing multiplication into addition, and this property was used a long time ago with our calculator's ancestors, the slide ruler. Right there, I'm showing you pictures on the right. I believe it used logarithms to simplify computations. So how does it change multiplication into addition? That's its first property, called the product rule. Okay, so we have some restrictions on the various variables. Of course, you could read that in the book. I'll just leave that to you. So the product rule is right there. Let's actually see what it looks like. So log base b of m times n is going to be log base b of m plus log base b of n. Okay, so it takes that multiplication and kind of turns it into an addition. Right? Okay, it's pretty simple. You just have to make sure that you apply it correctly, right? So let's take a look at some of these problems. Like number one, we have log base 9 of 2 times 11. So you could rewrite this as log base 9 of 2 plus log base 9 of 11. Okay. Let's see another one. Log base 6 of 6x. Log base 6 of 6x. So we could turn that into log base 6 of 6, which we can actually simplify, and then log base 6 of x. So log base 6 of 6 to what power is equal to 6, right? That's the question we kind of ask ourselves with regards to these logs. Whoops, 6 to what power equals not 1, but rather 6, right? So that's 1, and then plus log base 6 of x. So they want you to simplify these as much as possible and then type in your answer. Okay. For typing in logs, I don't know if I made that clear. You go 1 plus, and then you could just type log, but then you need instead of an exponent, you need to go down. So what I usually do is hit shift and then the minus key, and that brings you down. But there's also a little GUI button down here for subscripts. Okay. And next to all these buttons, it shows you how to actually type it in there. So if I wanted an uppercase delta, apparently, I can put slash and then C delta, and it will give me. So there's shortcut keys. If you got to use it all the time, it's not bad. Not a bad idea to know those shortcuts. Okay, so anyways, log base 6 of x, and check your answer. Yay. Right. Here's another one you could simplify, of course. We'll just do this one last one, I promise, and then we'll move on. So log of 100,000 x equals what? So you could split this into log of 100,000. This is the common log, so it has base 10, plus log of x. Okay, so it's basically you just count the number zeros, I believe. 1, 2, 3, 4, 5. So that's going to be 10 to what power equals 100,000? Well, that's just 5, and then plus log of x. Okay, so that should be easy to type in. 5 plus log of x. And I'm off the screen. Oops, there we go. Yay. All right. Again, I got rid of some of these, but just for the sake of sanity, hopefully there's enough in there for you to get enough practice. But you can always do problems from the book. So if you're feeling neglected, open the book. All right. So that's the product rule. The next rule is the quotient rule. Okay, and again, we have a bunch of restrictions on the variables involved. But anyways, let's just hand it to you. Quotient rule. Okay, a bunch of restrictions. If those hold, then log base b of m over n has to be equal to log base b of big M minus log base b of little n. Okay, so quotient, the log can turn a quotient into a subtraction. All right, so let's go back to the book and kind of look at some of these exercises. Where are you, exercises? Okay, so this is number 5. We have log of x over 100. It's a common log, so we'll probably be able to simplify a log of 100, right? So this will be log of x minus log of 100, which will be log x minus, I guess, 2. 10 to the second power is 2. So 10 to the second power is 100. I apologize. I don't know what I'm talking about sometimes. Log of x minus 2. And hopefully that will do it. Okay. Here's another one. So 6, so it looks like log base 5 of, I think it was 25 over y. Yeah. Okay, so this is going to be log base 5 of 25 minus log base 5 of y. And the first guy right there, 5 to what power equals 25, right? That's what's going on in my brain. So that's a 2. Then minus log base 5 of y. So I have 2 minus log base 5, arrow out, y. Natural log here. Let's see how many of these do I really want to do. I'll do this one and then we'll move on. So I think it's number 7, yeah. Natural log of e cubed all over 10. This will be the natural log of e cubed minus the natural log of 10. Of course, natural log is log base e, right? So here, this first expression is asking e to what power equals e to the third. And of course, that's just 3, so we'll have 3 minus ln of 10. 3 minus ln of 10. Check your answer. Yay. Okay, so a bunch of those. The last rule then is the power rule. So as usual, the book will give you a whole bunch of restrictions on the variables, and so long as those restrictions hold, we can apply this rule. And usually in practice, you don't have to worry too much about the restrictions. Log base b of m to some power p. Okay, so how does this work? You could take the p out of the exponent and drop it down in front of the log, and that's it. Base b of m. Okay. All right. So let's look at some of those problems. Where are you, problems? Okay. So I guess this is number 9. I'll be a little careful with your logs to write those parentheses in there, because as you see this problem, the a to the negative 4 is all inside the log, but that would be different than log of a all raised to the negative 4. So the power rule does not apply to this instance. Does not apply. Okay. Just like if you have log of, let's say, x squared, you can apply the power rule to that. You take the 2 and put it in front of the log, but the x squared has to be completely inside of the log. You can't say the log of x and all of that squared is equal to 2 log x. That won't apply there. Does not apply. Okay, so just be careful out there. So let's look at this log problem. They're giving us a to the negative 4. So I can bring the negative 4 in front of the log, and negative 4 log a. Okay. Oops, didn't want to do that. Oh wow, I got like, oh no, that's not very helpful. There we go. Right, there we go. Negative 4 log, make sure you use a capital A, so it will get really nasty if you don't. This is one of those ones where it looks like it's not, you know, the 4th root of x. I need to rewrite that. Okay, and you do that a lot later in math, rewriting these roots. So it really is the ln of x to the 1/4, and then you take the 1/4 and you put that in front of the ln x, and then you're done. Okay. All right. now what they're going to do is kind of put all the rules together, and there's two kind of like simplifications we could do. There's expanding logs. So what you're doing is taking one logarithm and writing it as a bunch of different logarithms. And there's also going to be condensing. So you're taking a bunch of logarithms and writing it as one logarithm. Okay, for expanding logarithms, what you want to do first is your product rule and your quotient rule. Quotient. And then lastly, do your exponent rule. I believe that'll kind of help you. Okay, so for instance, number, I don't know what number this is, and it's not showing me. Oh, question 11. There we go. For number 11, I have log base b of z to the fifth y. So what you don't want to do is like try to take that 5 and put it in the front. That won't work because the exponent 5 is not attached to the y. It would have to be attached to the z and the y. So it'd have to be like zy in parentheses to the fifth to use the exponent. So what I say, break them up first using the product or the quotient rule. So you have log base b of z to the fifth plus log base b of y. And then you could do exponent, the product rule. What the heck are you calling that? The power rule. Sorry, I'm calling it the exponent rule or something. I don't know. Power rule. All right, so you could bring that 5 in front of the log, and then plus log base b of y. So they want you to get rid of all the exponents and break up all of the products and quotients, and that would be that right there is your answer. So 5 log base b of z plus log base b of y. Whoops. Okay. And you know, they're going to really challenge you with these. They make them harder and harder, but it's good practice. You should be able to do these almost in your sleep. Let's look at number 13. I have log base 3 of 9 all over the square root of x plus 6. So what I'm going to do first is break it up using the quotient rule. Right? So log base 3 of 9 minus log base 3 of x plus 6, square root of. I'm not going to write the square root though because it's really just a power. So I'm just going to put the power there. Log base 3 of 9, that's asking 3 to what power equals 9. Right? I can simplify that. That's just 2. And then minus 1/2, I'm going to bring down the power, log base 3 of x plus 6. Right? Let's make sure it works. Yay. This guy, so I think number 14, we have log base b of x cubed y all over z cubed. Okay. So again, first I'm going to break it up. I'm going to do the quotient rule. So I guess I'd usually do the quotient before product. So let me rewrite this just a little bit if you don't mind. I'm going to say, let's do, always keep it in this order. And I mean, I say always, but there, you know, a lot of times there are exceptions. So quotient, then I do product, then I do powers. And then when we condense, we're just going to go kind of in the opposite direction. So here I'm going to do the quotient, log base b of x cubed y minus log base b of z cubed. Then I'm going to do a product rule on this guy. So I have log base b of x cubed plus log base b of y minus log base b of z cubed. And then I can go ahead and do power rules. So it's 3 log base b of x plus log base b of y minus 3 log base b of z. And that should be your answer. Okay. So 3 log base b of x plus log base b of y minus 3 log base b of z. Okay. Okay, so So this one okay, so what is this, number 15? So there is a product in there, but it's inside that square root. So if you take a closer look and rewrite it, you have 100y to the 1/2. So there's two things you could do. You could do a power rule here, but if you want to be, you're really intent on using my system, you could distribute that 1/2 and then use a product rule, right? So log of 100 to the 1/2 minus log of y to the 1/2, or sorry, plus, right? Because it's a product rule. But if you didn't want to, there's more than one way to skin the cat. You could say this is just 1/2 log of 100y, right? And then that would be 1/2 times log of 100 plus log of y. And you see what you're going to get is just the same thing as you would get if you took the power rule right here. So 1/2 log of 100 plus 1/2 log of y, right? Because that thing I just wrote is the same thing as this thing, but with the 1/2 distributed. For my final step, I'm going to simplify that part, right? So that asks 10 to what power is 100, so that would just be 2, and then plus 1/2 log of y, and that would just be 1 plus 1/2 log y. Okay, so more than one way to skin a cat. I try to give you kind of helper methods, but sometimes there's more than one way to do it. I'm cool with that. Right. Oh, here's a nasty looking one. Let's try this, and then we'll go and work with condensing. So 17, I have log base g. Let's make this a video quiz for the day. Okay, let me put that in my notes. This is the third video quiz in section 12, so 12.3, number 17 from my math lab. Okay, so log base, and that is a g as in gangster. Okay, so log base g of square root of a b cubed all over c to the 7th. So first I'm going to do the quotient rule. So log base g of square root a times b cubed minus log base g of c to the 7th. Then I'm going to use a product rule on this guy. So I have log base g of a. I'm going to rewrite that square root as 1/2 power plus log base g of b cubed, and then log base g of c to the 7th. And then you just do power rules. So you get 1/2 log base g of a plus 3 log base g of b minus 7 log base g of c. Okay, you need to type that in. 1/2 log base g of a plus 3 log base g of b. It's really b. Okay, minus 7 log base g of c. Okay, great. Another one here, I do the power rule first on this guy because that cube root is really parentheses to the 1/3 power, and then you could start splitting up the log, but then you would have to distribute the 1/3 to all the terms. I'm going to leave that one for you, right? Okay, now we're going to start condensing logs, so we're going in the other direction. They'll give you a sum and difference of logs, and then you have to change it into one log, okay, with no coefficient, no number in front of it. So condensing logs, and let's take a look. So let's skip this one. Seems like I'm doing too many. Number 20, I have ln of x plus ln 5. So you just reverse the product rule. That'd be ln of x times 5, or 5x if you'd rather. Right. Okay. Let's skip this one. So this is 22. We got log of 4x plus 1 minus log of x. You just use quotient rule, right? That's log of 4x plus 1 all over x. If you don't mind, I'm not going to type that in. Okay, so before I kind of tried to lay out a program that you could follow, quotient, product, and power. Now I'm going to be doing things in the reverse order, right? So first I'm going to do power, then I'll do quotient, or sorry, then I'll do product, and then I'll do quotients. I'll try to keep that, but sometimes, there's a million ways to skin a cat. So, all right. So anyways, here 24, we have 4 log base b of x plus 7 log base b of z. So I want to do power rules first. So I have log base b of x to the 4th plus log base b of z to the 7th. Okay, and then I'm going to do product rule. Log base b of x to the 4th, z to the 7th. Okay. This is sort of the same thing, except you do a quotient rule, number 25 there. So power, then quotient. This would be power, then quotient. Wow, look at that one, right? Let's try that one on for size. So this is number 28. I have 1/2 times log base 7 of x plus log base 7 of y minus 3 log base 7 of x plus 6. Okay, I'm going to distribute this first. I can't do a power rule. It wouldn't work. I mean, you could do a product rule if you'd rather do that, but I'm going to distribute it first. Okay, x plus log 1/2. Whoops. Log base 7 of y minus 3 log base 7 of x plus 6. Okay, once I get it in that form, I could do 3 power rules. So I got log base 7 of x to the 1/2 plus log base 7 of y to the 1/2 minus log base 7 of x plus 6 to the 3rd. Then I'm going to do a product rule on those first 2 terms. So log base 7 of x to the 1/2 times y to the 1/2. You could rewrite that just as square root x times square root y, which would be square root xy. And then minus log base 7 of x plus 6 to the 3rd. Then I'm going to do a quotient rule. So log base 7 square root xy all over x plus 6 to the 3rd. And all of that junk is inside the log. Okay. So if you want to, I'll type it in log base 7 of square root of xy. Whoops. You have to put a little slash in front of sqrt, right? And then you can just pop the xy in there. And then divided by x plus 6 to the, so you do the caret key 3rd. Yay. Okay, so those get harder and harder. One problem with some calculators is there is no LOG button on the calculator. I think maybe I kind of complained about that in one of the last videos. To get around it, what you do is use this change of base formula. So clearly your calculator does not have a log base 14 key on it, right? So, but you're still going to be asked to sometimes figure out log base 14 of 18. So what do? You have the ln key. So I just always use ln, and you could go ln of 18, the bigger number, divided by ln of 14. And then if you put that in your calculator, you should be good to go. Okay, so I go ln of 18 divided by ln of 14. I'm getting 1.095er. Yeah, I already did that one. Okay. So it's pretty simple, like this guy. I'll do one more, and then I think that'll be it for me. Log base 15 of 87.5. This is going to be the ln of 87.5 all over ln of 15. ln of this big all over the ln of the small. It's going to be 1.65. How many? 4 decimals. Geez, 1.6512. So make sure you can do that every once in a while. It's handy. Is that about it? I must have deleted a whole bunch I didn't like. Okay. All right. Thank you for watching as usual, and I'll see you next time.